Good morning to all present. Welcome to the celebration of National Mathematics Day 2020, organized by Department of Applied Mathematics, DIT Durg. The contribution of Indian scholars to the study of mathematics can be traced back as early as 1200 BC. We are proud citizens of the motherland of great mathematicians like Aryabhat, Brahmagupta, Bhaskar II, Mahavir, Shakuntala Devi, Srinivas Ramanujan, to name but a few. Discoveries like the concept of zero as a number, modern definition of sine and cosine, series expansion of trigonometric functions, and many such others have made an undeniably bold mark in the field of mathematics. However, in the recent decades, the attention to this field of science in India has been wavering. So, for concentrating our efforts in making the citizen of India aware of the integral part mathematics plays in the development of humanity and for developing a logical and precise mindset among the young generation, the then Prime Minister Dr. Manmohan Singh paid tribute to the 125th birth anniversary of Ramanujan as National Mathematics Day on 22nd December 2012. Since then, National Mathematics Day has been celebrated in India, all over India, on 22nd December. Srinivas Ramanujan, the genius, was regarded at par with Euler and Jacobi from 18th and 19th century. Born to a traditional Tamil Brahmin family, he gave an entirely new connotation to the mathematics. He completed 4,000 mathematical equations and results, including the number theory, fractions, infinite series, and many others that opened new avenues for mathematical research. Ramanujan solved the regular mathematical problems at the age of 10 without any formal training. He is truly recognized and regarded as a visionary who changed the description of mathematics and opened a whole new world of avenues to the field. To further elucidate about the great mathematician and to throw some light on his numerous contributions to the field of mathematics, we have with us Dr. Tanmoy Som. Professor Som is presently gracing the position of Head of Department of Mathematical Sciences in IIT BHU Varanasi since 2018. He has extensive experience, 35 years in teaching and research. 14 research scholars have been awarded PhD degree and 9 are presently working under his guidance. He has to his credit publication of 64 and 40 research papers in national and international journals of good repute. Also, he has edited international proceeding for conference organized under the wing of the publishing house Springer. He has delivered invited talks in 37 national and international conferences and 17 STC FDP. He has provided services as resource person for FDP organized at Guwahati University, Manipur University, IAST Guwahati, IIEST Shivpur, Kalyani University, MITS Gwalior, GEC Jabalpur, and etc. Also, he has delivered talks worldwide in Texas AM University, Kings Valley, Texas, USA, Northern University at Chiang Rai, Thailand, and University of California, Berkeley, USA. He has successfully completed the project of about 23 lakhs sponsored by BRNS BARC during 2014-18. He has organized 3 national conferences, 1 winter school sponsored by ISI AU, international training workshop, STC, etc. He also have extensive experience of handling editorial office and reviewing many research papers of highly reputed journals. We are hopeful of having a deep insight into the life and work of the great mathematician Srinivas Ramanujan through the knowledge and vision of Dr. Tanmoy Som. Please, sir.
Hello, are you able to? Hello, 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 हेलो। आ रही है? अच्छा, वही तो मैं चाह रहा था कि मैं आ रहा हूँ कि नहीं। हाँ, अच्छा। उसके बाद मैं शेयर भी करूँगा, तो वो शेयरिंग देख लीजिएगा आ रहा है कि नहीं। या अच्छा, ठीक है, ठीक है। वो वहाँ पे शेयर पे जाएंगे तो वहाँ से कर सकते हैं ना, शेयर स्क्रीन में। ठीक है, ठीक है, ओके। So first of all, I thank Mr. Dr. Anil Kumar Dubey of BIT Bhilai for inviting me for a talk on the occasion of Ramanujan's birthday. I'm really thankful to him. We are actually also organizing a program, 2 days program. So I have taken some half an hour time to share with you some knowledge from the uh, notebooks of Ramanujan. Let me share my slides. No, it is not yet shared. বাবু একবার দেখবি এটা শেয়ার কি করে হবে। ইয়াতে স্লাইড শোটা, এটা একটা অন্য একটা ইয়ে। এখানে বসে যা, এখানে আছে স্টপ শেয়ারিং, প্রথম বন্ধ কর, স্ক্রিন শেয়ার। কোনটা আসবে? উপরেরটা আসবে, উপরেরটা এই হোটেলে ক্রোম। আচ্ছা আচ্ছা, ইয়েতে আছে উইন্ডো, ইয়ে উইন্ডো। ইয়া, ঠিক আছে। Are you getting the slides? Hello? Hope you are getting the slides. So I have with us the some contributions of Srinivasa Ramanujan. In fact, he born on December 22nd, 1887 in the small town of Erode, Madras Presidency, British government, under British government, and lived for only 32 years. On April 26, 1920. His other name was Srinivasa Ramanujan Iyengar. He was also a member of the Fellow of the Royal Society of London. He was awarded that particular award because of his works. A famous history is about in school days about him is like this. One day, during his early school days, his class teacher of third standard was telling to his students, if there if three apples are divided among three persons, each would get one, and generalize this that any number divided by itself would give unity. Immediately, a boy of the class jumped and asked, "Is 0 divided by 0 unity?" This little boy was none other than Ramanujan. So, this type of questions, crazy questions, used to be there always in his mind, and that has given a lot of enthusiasm to work some new problems. Srinivasa Ramanujan Iyengar was an Indian genius who lived during the British rule in India. Though he had almost no formal training in pure mathematics, he made substantial contributions to mathematical analysis, number theory, infinite series, continued fractions, including solutions to mathematical problems then considered unsolvable. Ramanujan initially developed his own mathematical research in isolation, of course, according to Hans Eysenck. He tried to interest the leading professional mathematicians in his work, but failed for a long time or most of the part. What he had to show them was too novel, too unfamiliar, and mostly presented in unusual manner. Seeking mathematicians who could better understand his works, in 1913 he began a postal communication with English mathematician Professor G.H. Hardy at the University of Cambridge, England. Recognizing the works of Ramanujan as extraordinary, Hardy arranged for his travel to Cambridge. In his notes, Hardy commented that Ramanujan had produced groundbreaking new theorems, new results, including some results that defeated me completely. I had never seen anything in the least like them before, and some recently proven results, but highly advanced results, proven and highly advanced. During his short life, Ramanujan independently compiled nearly 3,900 results, mostly identities and equations. Many were completely novel. His original and highly unconventional results, such as the Ramanujan prime, Ramanujan theta function, partition formula, Mach theta functions, have opened entire new areas of work and inspired a vast amount of further research. Nearly all his claims have now been proven correct. Ramanujam Journal is a scientific journal, is published, was established to publish work in all areas of mathematics influenced by Ramanujan. And his notebooks containing summaries of his published and unpublished results have been analyzed and studied for decades since his death as a source of new mathematical inspiration and ideas. As late as 2011 and again in 2012, researchers continued to discover that mere comments in his writings about simple properties and simple outputs for certain findings were themselves profound and subtle number theory results that remained unsuspected until nearly a century after his death. He became one of the youngest fellows of the Royal Society and only the second Indian member and the first Indian to be elected as a Fellow of Trinity College, Cambridge. Of his original letters, Hardy stated that a single look was enough to show they could have been written only by a mathematician of highest caliber, comparing Ramanujan to mathematical genius such as Euler and Jacobi. In 1919, due to ill health, now believed to have been hepatic amoebiasis, Ramanujan was compelled to return to India, where he died in 1920 at the age of 32. His last letter to Hardy, written in January 1920, shows that he was still continuing to produce new mathematical ideas and theorems. His last notebook, containing discoveries from the last year of his life, caused great excitement among mathematicians when it was discovered in 1976. Some of his major works are, or particularly he is famous for, Landu Ramanujan constant, Mach theta function, Ramanujan conjecture, Ramanujan prime, Ramanujan solder. Just wait. Uh, Ramanujan Soldner constant, Ramanujan theta function, Ramanujan sum, Roger Ramanujan's identity, Ramanujan master theorem, Ramanujan Sato series. There are few more. Hypergeometric and Q hypergeometric series, partitions and combinatorial analysis, additive number theory via circle method, probabilistic number theory, elliptic and theta functions, modular forms and automorphic forms, continued fractions, Diophantine equations, Fourier analysis, even Lie algebra, and computer science and computer algebra. Ramanujan has made and enormous contributions in the area of analytical number theory, which includes congruences, Diophantine equations, continued fractions, magic squares, theory of partitions, concept of highly composite numbers, elliptic functions, expressions of pi, Ramanujan's number, and a symmetric equation and Ramanujan's equation. Ramanujan is recognized as one of the great number theorists of the 20th century. Here now is the first book to provide an introduction to his work in number theory. Most of the Ramanujan's work in number theory arose out of Q series and theta functions. He has also coined the theory of partitions, sums of squares and triangular numbers, and the Ramanujan's tau function. The majority of the results discussed are the original work due to Ramanujan and were discovered by himself. Ramanujan did not leave us proofs of thousands of theorems he recorded in his notebook. So these were nothing but uh, unproved results. Okay, and so it cannot be claimed that many of the proofs given in his book are those found by Ramanujan. However, they are all in the spirit of his mathematics. One of the known conjecture as Goldbach conjecture is one of the important illustrations of Ramanujan contribution towards the proof of conjecture. The statement reveals that every even integer that 2 is the sum of 2 primes. Every integer greater than 2 is sum of 2 primes, just like 6 equal to 3 plus 3. Ramanujan and his associates had shown that every large integer could be written as either sum of 2 integers or sum of at most 4 primes, like 43 is equal to 2 plus 4 plus 17 plus 19, and so on. There are plenty of such examples. For example, this 4 can be written as 1 plus 3 2 plus 2, 1 plus 1 plus 1 plus 1, then like this. This is called partition of 4. Okay. Similarly, 6 can be written as 3 plus 3. There are many other partitions of 6, and like that. 8 is 3 plus 5. This is nothing but sum of primes. But this is another point. There is a partition. Okay. That is not shown here, but maybe I will have another slide. Okay. So partition, that is P bracket N, can be written as partition. Okay. The partition of whole number, yeah. The partition of whole number is another similar problem that captured Ramanujan's attention. Subsequently, Ramanujan developed a formula for partition of any number which can be made to yield the required result by a series of successive approximations. For example, 3 has 3 partitions, that is 3 is equal to 3 plus 0, 1 plus 2, 1 plus 1 plus 1, like that. Okay. So we have a formula. Similarly, the Ramanujan studied the highly composite numbers also, which are recognized as the opposite of prime numbers. He studied their structure, distribution, and spatial forms. The fundamental theorem of arithmetic is an important contribution in this regard. Every composite number greater than 2 is product of primes. Hello? Hello? हाँ, स्क्रीन शेयर तो मैंने किया था. अरे क्या चक्कर, नहीं आ रहा है. एक मिनट, फिर से लगता है स्टॉप हो गया था. पहले आया था ना एक बार. अच्छा, ओहो, पहले ही बोलना. एनीवे, इसमें कुछ देख रहा हूँ. देखिए शेयर हो रहा है कि नहीं. अरे यहाँ से तो मैं शेयर कर रहा हूँ, लगता है आपके यहाँ से कहीं. नहीं, ये जब तक नहीं दिखेगा तो फिर मजा नहीं आएगा, पूरा मर्जा ही खत्म हो जाएगा. शेयर तो होना चाहिए एक्चुअली. जब मैं शेयर लगा रहा हूँ अभी, इसमें 2 ये आ रहा है कि स्ट्रीम कॉम इज शेयरिंग ए विंडो. अच्छा, एक मिनट, फिर से मैं देखता हूँ एक और. इसमें तो दिखा रहा है. अच्छा, अच्छा स्टॉप. जबकि आना चाहिए. आपके नीचे जो यहाँ पे लिखा है शेयर स्क्रीन, इसी को क्लिक करने से आएगा ना. वहाँ पे भी फिर शेयर स्क्रीन आ गया, तो उसके बाद में हमारा जो विंडो है. हाँ, अच्छा, हाँ, एप्लीकेशन विंडो लिखा है, ठीक है. हाँ, उसी में तो आना चाहिए. मैं प्रेजेंटेशन को क्लिक किया हूँ और फिर शेयर आ गया है, लेकिन फिर मैं क्लिक कर रहा हूँ तो आपके वो में क्यों नहीं आ रहा है. अच्छा, यहाँ पे कहीं ओके कहीं दिख तो नहीं रहा है. अच्छा, राइट हैंड साइड में एक शेयर है. अच्छा, एक मिनट में देखता हूँ. हाँ, देखिए आया क्या शेयरिंग. शेयर सेव टू क्लाउड. अच्छा, आ जाएगा. कुछ एक प्रॉब्लम है. क्यों नहीं आ रहा है हमको नहीं समझ में आ रहा है. एक्चुअली कल एक ट्राई ले लेना चाहिए था. आ गया. अच्छा चलिए ठीक है. चलिए तो फिर मैं अभी से शुरू करता हूँ. जस्ट हाफ एन आवर आई विल बी हैविंग. So this is nothing but some contributions of Srinivas Ramanujan. Let me repeat everything. Srinivas Ramanujan, born on December 22nd, 1887, in a small town, Erode, under Madras Presidency during British Raj. Hello. अच्छा F5 ना. आ गया. अच्छा चलिए ठीक है. अब आया. हमको भी एक्चुअली उस समय नहीं आया था. There is a famous history about Ramanujan. One day during his early school days, his class teacher of third standard was telling to his students, if 3 among 3 persons, each would get 1, and generalized this concept that any number divided by itself would give unity. Immediately, a boy of the class jumped and asked, "Is 0 divided by 0 unity?" This little boy was none other than Ramanujan. So, such curious Ramanujan was there during his school time itself. Srinivas Ramanujan Iyengar was an Indian genius who lived during British rule in India. Though he had almost no formal training in pure mathematics, he made substantial contributions to mathematical analysis, number theory, infinite series, and continued fractions, including solutions to mathematical problems then considered unsolvable. Ramanujan initially developed his own mathematical research in isolation, according to Hans Eysenck. He tried to interest the leading professional mathematicians with his work, but failed for most of the part. What he had to show them was too novel, too unfamiliar, and mostly presented in unusual manner. Seeking mathematicians he could better understand his works, in 1913 he began a postal communication with the English mathematician Professor G.H. Hardy at the University of Cambridge, England. Recognizing the works of Ramanujan as extraordinary, Hardy arranged for his travel to Cambridge. In his notes, Hardy commented that Ramanujan had produced groundbreaking new theorems, including some results that defeated me completely. I had seen everything. I can say anything in the least like them before. Just wait. I had never seen anything in the least like them before, and some recently proven but highly advanced results. During his short life, Ramanujan independently compiled nearly 3,900 results, mostly identities and equations. Many were completely novel, his original and highly unconventional results, such as Ramanujan's prime, Ramanujan theta function, partition formula, Mach theta functions, which have opened entire new areas of work and inspired a vast amount of further research. Nearly all his claims have now been proved correct. The Ramanujan Journal, a scientific journal, was established to publish his works in all areas of mathematics influenced by Ramanujan, and his notebooks containing summaries of his published and unpublished results have been analyzed and studied for decades since his death as a source of new mathematical inspiration and ideas. As late of as late as 2011 and again in 2012, researchers continued to discover that mere comments in his writings about simple properties and similar outputs for certain findings were themselves profound and subtle number theory results that remained unsuspected until nearly a century after his death. He became one of the youngest fellow of the Royal Society and only the second Indian member and the first Indian to be elected as fellow of Trinity College, Cambridge. Of his original letters, Hardy stated that a single look was enough to show they could have been written only by a mathematician of highest caliber, and comparing Ramanujan to mathematical genius such as Euler and Jacobi. In 1919, due to ill health, now believed to have been hepatic amoebiasis, Ramanujan was compelled to return to India, where he died in 1920 at the age of 32. His last letter to Hardy, written in January 1920, shows that he was still continuing to produce new mathematical ideas and theorems. His lost notebook, containing discoveries from the last year of his life, caused great excitement among mathematicians when it was discovered in 1976. He became famous for Landu Ramanujan constant, Mach theta functions, Ramanujan's conjecture, Ramanujan's prime, Ramanujan's Soldner constant, Ramanujan theta function, Ramanujan's constant sum, Roger Ramanujan identities, Ramanujan master theorem, Ramanujan Sato series. Some more are like this: hypergeometric and Q hypergeometric series, partitions and combinatory analysis, additive number theory via circle method, probabilistic number theory, elliptic and theta functions, modular forms and automorphic forms, continued fractions, Diophantine equations, Fourier series, Lie algebra, even in computer science and computer algebra. Ramanujan has made enormous contributions in the area of analytical number theory, which includes congruences, Diophantine equations, continued fractions, magic square, theory of partitions, concept of highly composite numbers, elliptic functions, expressions for pi, Ramanujan's number, a symmetric equation, and Ramanujan's equation. He is recognized as one of the great number theorists of the 20th century. Here now is the first book of to provide an introduction to his work in number theory. Most of the Ramanujan's work in number theory arose out of Q series and theta functions. He also coined the theory of partitions, sums of squares, triangular numbers, Ramanujan's tau function. The majority of the results discussed are the original work due to Ramanujan were rediscovered by him. Ramanujan did not leave us proofs of thousands of theorems he recorded in his notebook, and so it cannot be claimed that many of the proofs given in his notebook are those found by Ramanujan, because many theorems, many proofs are now added there. Okay. However, They are all in the spirit of his mathematics. The very good result is the Goldbach conjecture. Goldbach conjecture is one of the important illustrations of Ramanujan's contributions towards the proof of the conjecture. The statement reveals that every integer greater than 2 is sum of two primes. That is, 6 is 3 plus 3. Similarly, say 7 is 3 plus 4, like that. Ramanujan and his associates had shown that every large integer could be written as the sum of at most 4 primes. Say 43 is equal to 2 plus 5 plus 17 plus 19, like that. No need, no more. Okay, like that. So even number 4 has sum of 2 primes, like this. 1 plus 3 and 2 plus 2, like this. 6 can be written as 3 plus 3. 3 can be written, okay, 3 is a prime. 8 is 3 plus 5. 10 is 5 plus 5, like this. Then we have partition. The partition of whole number is another similar problem that captured Ramanujan's attention. Subsequently, Ramanujan developed a formula for partition, that is Pn. We have one formula of number which can be made to yield required result as a series of successive approximations. Say 3 is nothing but 3 plus 0, 1 plus 2, 1 plus 1 plus 3. Similarly, 5 is 1 plus 4, 2 plus 3, uh, 1 plus 1 plus 1 plus 1 plus 1, 1 plus 2 plus 1 plus 1, like this. There are similar partitions for every number. We have partitions. Okay, and this number of partitions are finite because my number is finite. Okay, the numbers, that is, Ramanujan studied highly composite number also, which are recognized as the opposite of prime numbers. He studies their structure, distribution, and spatial forms. The fundamental theorem of arithmetic is an important contribution in this connection. Every composite number greater than 2 is product of primes. That is the fundamental theorem of arithmetics. Then the Fermat theorem. He also did considerable work on the unsolved Fermat theorem, which states that a prime number of the form 4m plus 1 is sum of two squares. Then we have very important number, what is called Hardy Ramanujan number. Once Hardy visited, there is a story. Hardy visited Ramanujan when he was hospitalized in Putney. Hardy traveled in a taxi cab having number 1729, which seems to be unlucky to Hardy due to some superstition. When he told Ramanujan that he just came in a taxi cab with number 1729, Ramanujan immediately replied that it is the smallest number which can be expressed as sum of two cubes in two different ways. That is, 1729 is 1 cube plus 12 cube. That is also equal to 9 cube plus 10 cube. Later, 1729 was known as famous Hardy Ramanujan number. There are many similar examples as mentioned below, like this. Say 4104 is 2 cube plus 16 cube, or 9 cube plus 15 cube. Okay. Similarly, 13832 is 2 cube plus 24 cube, or 18 cube plus 20 cube. So this can be written as a number n can be written as x cube plus y cube, and that is same as again a cube plus b cube. So there are two pairs of numbers whose sum of cubes is that number. Okay. So then there is something more, that is cubic equation and quadratic equation. Ramanujan has shown how to solve cubic equation in 1902, and he went on to find his own method to solve quadratic equation. The following year, not knowing that the quintic could not be solved by radicals, he tried, and of course, failed to solve a quintic equation that is more than power 3. Okay, quintic equation having. So he has been successful in solving quadratic equation and cubic equation even in 1902. This is the infinite series given by Ramanujan, that is 2 sine pi by 18 is nothing but 2 root 2 minus again root 2 plus q root 2 plus root 2 minus. Now this is a period like this, root 2 minus root 2 plus root 2. This is a period 3 minus plus plus. So this was discovered by Ramanujan. This is the sine series of pi by 18. In 1904, Ramanujan had begun to undertake deep research. He investigated the series 1 by n and calculated this Euler's constant. This sum 1 by n, this is nothing but, okay, okay, that I will show it later. The calculated Euler's constant to 15 decimal places. These are all very important contributions. Similarly, Ramanujan also discovered remarkable infinite series for pi in during or around 1910, given by 1 by pi is equal to 2 root 2 divided by 9801 summation k 0 to infinity 4k factorial 1103 plus 26390 divided by k factorial to the power 4 396 to the power 4 k, which computes pi with each term in series correct up to 8 decimal places. Later on, a number of efficient algorithms have been developed based on the above formula for computing pi. Okay, this has led many mathematicians to work on it to get pi to higher, correct up to higher decimal places. He worked on hypergeometric series and investigated relations between integrals and series. He later discovered that he had been studying elliptic functions. Ramanujan's own works on partial sums and product of hypergeometric series have led to major development in the topic and that topic. I have some more that is not in slide. Let me show you uh, another astonishing formula given by Ramanujan, that is 1 plus 2 plus 3 plus 4 dot dot dot. That sum is nothing but minus 1 by 12. The reasoning is very simple. If I show you, probably it will be reversed in your screen, but I can tell you here. Say 1 plus 2 plus 4 plus dot 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 is C. Then multiplying by 4, I can write it 4 plus 8 plus 12 dot 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 is equal to 4C, and writing 4 below 2, 8 below 4, and so on. Subtracting, we get 1 minus 2 plus 3 minus 4 plus 5 minus 6 is equal to minus 3C. Observe that 1 minus 2x plus 3x square minus 4x cube dot 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 is nothing but 1 by 1 plus x whole square. This is a well-known result. Taking x equal to 1, what we get? 1 minus 2 plus 3 minus 4 dot 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 is equal to 1 by 4, and that is the same series which Ramanujan calculated, and that is nothing but same as minus 3c, and therefore c is equal to minus 1 by 12. So this is the really a very wonderful result derived by Ramanujan during his time. Another thing about his birthday, he has worked on magic square. If you just see here that his birthday, that is 22/12/1887. So this is 22/12/1887, and he has made this magic squares, sum of each row, sum of each column, diagonal sum, they are same. If you can have a look, this is the magic square uh, on his birthday, date birthday. And Hardy himself, let me share one more screen, let me see whether it is here or not. How much time is there? Can I share one more slide? Yes. To share. Are you getting the slide? Yes. Hello. Yeah. The two examples of results communicated by Ramanujan in his letter to Hardy in 1913. It is about what is called continued fraction. This is a continued fraction given by Ramanujan, that is 1 plus 1 divided by 1 upon 1 plus e to the power minus 2 pi root over 5 divided by 1 plus e root over e to the power minus 4 pi by 5 divided by 1 plus, this is a continued fraction like this sum is given by this, okay, that is ultimately root 5 by 1 plus 5, okay. I think this slide is not visible, is it? Yeah. Anyway, I think अभी नहीं आया, अच्छा अच्छा, एक मिनट मैं देखता हूँ फिर से एक और स्लाइड. अच्छा एक मिनट. ये कुछ दूसरा एक ऊपर में आ गया है. Let me again. ये क्यों आ गया? ओके. ओह सॉरी, मैं अच्छा आभास मैं आ रहा हूँ, जस्ट मैं दूसरे जगह एक लेक्चर दे रहा था, मैं 2 मिनट में ज्वाइन कर रहा हूँ. या ओके आई जस्ट फॉरगेट इट. ओके. I think I have to say thank you because I have another lecture in another place to. So I stop here with my lecture. It because of some delay I have to start another program. Okay, thank you very much. Yeah,
Thank you
please
very
don't
much.
mind. Yeah.
Thank you very much, Dr. Tanmoy. So, your talk on the topic Ramanujan and
Yeah.
its contribution in the field of mathematics was very enlightening. I am sure that students and faculty members alike were enriched with knowledge this hour. Myself, Dr. Sanjay Sharma, head of the Department of Applied Mathematics, on behalf of my department, thank you very much for sparing your valuable time and energy for your benefit. I also thank the college management and administration for providing us this opportunity of the showcasing the life and contribution of great mathematician as a attribute to the same. Thank you, one and all. Now I hand over the mic Dr. Anindita Chakravarti to conducting the quiz competition. Thank you very much, sir.
Thank you once again. Now I am declaring the start of the quiz competition. The link for the quiz is will be displayed on the screen also, and it has been sent to the first year groups. You will go to the link for Google form and open it. Now you will find it is open. You will be able to respond to the form. Respond to the form. The time is 10 minutes. Exactly, if you say it will be 12 minutes exactly. At 12 o'clock, the quiz will be closed and you will not be able to submit your answer after that. You have 12 minutes. Before 12 o'clock, you will submit your answers. Otherwise, will not be submitted after 12 o'clock. It will be closed after 12 o'clock. Students, due to technical difficulty, we have extended the time up to 12:10. The quiz will remain open up to 12:10. You can submit your answers up to 12:10 p.m. And the result of this quiz will be declared on your respective WhatsApp group for which is used for official WhatsApp group which is used for your section. The result will be declared in your respective class groups at 3 p.m. today.